Good morning, everyone, and welcome to the very first virtual field trip for Blazing Trails. First, I'd like to say that we're going to get started at 10 a.m., but if you guys haven't already downloaded those worksheets that go along with this, make sure to click the link in the description, and it will take you right to the page where you can download those for free. Just make sure to fill out a few questions first, and then you can use those as the tour begins. That's going to start at 10 a.m., so we'll wait for now, and then we'll come back and get you in a few minutes, okay? Hi guys, once again welcoming you all to the virtual field trip for Blazing Trails at Larsen Motorsports. One thing I want to tell you, if you haven't already gotten those worksheets, to go ahead and download them with the link that's in the description below this video. Those will help you on your way through this tour. You can answer the questions. The questions are not necessarily in order, so keep that in mind. You might have to rewind the video at certain parts if you don't get the answer, but I promise you all of the answers will be in this video. All right, thanks.
Hi everybody, I'm Chris Larsen and welcome to the first Blazing Trails virtual tour. We're doing this right here today at our partners, Larsen Motorsports. You're going to see a lot of really great stuff today. Follow us, be sure to follow us on YouTube, Instagram, Twitter, and be sure to follow along with this tour just like Logan's been telling you. All of the answers to those questions that you have on the test that you downloaded will be in this tour today. Today, we are going to give you a tour of Larsen Motorsports. It's a virtual tour that is going to show you exactly what we do here at Larsen Motorsports every single day. And one of the things that we do is racing. What type of racing do we do? We do jet racing. We're going to show you exactly what's involved with all of jet racing, and we're going to tell you a lot about STEAM education, science, technology, engineering, arts, and math. One of the things that you can do is follow us throughout the video here. Our Director of Operations, Brian Tachi, is right there at that computer. He is going to be answering all of your questions, all of your comments. Please do that. Please give us all the questions and comments that you can, because we are live with you for this next hour. Come on this way, and we're going to start our tour. One of the things that Larsen Motorsports does is works with universities, and we are literally right here on Florida Space Coast in Melbourne, Florida, at the Florida Institute of Technology. A lot of students work with us every single day. And so those students are going to be doing a bunch of different projects in all of those areas that you see throughout Larsen Motorsports. And we're going to tell you a lot more about those in subsequent videos, subsequent live tours. We know you have a lot of questions. We're going to focus today I'm giving you an overview of Larsen Motorsports, and then in subsequent videos and live tours, we are going to give you specific areas. So we're going to watch all of your questions and comments and make extra sure that we cover every single one of those. Right behind me, though, is a turbine engine test platform. Now, this turbine engine test platform was literally built by Florida Institute of Technology students. There's a lot of things that we do with this, but one of the things that we do is testing engines that we build right here at Larsen's for leaks. We also make sure that those engines actually run to all the parameters that we tune them to. And then, very, very important, we're really into renewable energy. Earth Day is coming up soon, and some of the things that we've done with this are literally testing renewable energy and renewable fuels. Trust me when I say this test platform was built as an entire renewable energy research project by students right here at Florida Institute of Technology. We're moving on down a little bit further. We're going to take you through a bunch of really neat spaces right here at Larsen Motorsports. And you can see that the types of vehicles that we build here at Larsen Motorsports are certainly jet racing vehicles. But one of the things that we do is teach a lot of things about all high-performance vehicles that cover things like electric vehicles, magnetic levitation trains, hybrid vehicles. We build jet cars. We build two types of jet cars. You're going to learn a lot more about those in just a few minutes. But basically, those two types of jet cars that we build are jet dragsters and jet funny cars. Coming on down this way, you're going to see a vehicle behind me that's really special and near and dear to our heart, and that is the Miller Welding Jet Dragster that our driver, Elaine Larsen, that drives the Florida Tech Jet Dragster right now, actually won 2 IHRA World Championships with. And she did that with students crewing the car. In fact, in 2015, she did it with an all-female crew that crewed the car to those world championships. It was really, really big deal for us to win those 2 world championships. Coming on down this way, well, you have great days at the racetrack, and then you have days that aren't as good. This was definitely the product of one of those days, but it was a pivotal moment in our career here at Larsen Motorsports. This car behind me had a crash in 2010 at 280 miles an hour. Elaine was driving the car. The car was pretty new, and it did its job to protect her for the most part. But she ended up with some broken bones. She ended up with a lot of bumps and bruises, and really important, she ended up with what we call a subdural hematoma, where she actually had a brain bleed that was bleeding between her brain and her skull. That is really important because everything that we do here is completely real. But the day that happened was the day that we really looked at a lot of things like human-centered design, human factors. Before this, it was about putting a human being in a race car. After this, it was about building a race car around a human being. And that's one of the things that we've really learned a lot about living here on Florida Space Coast. In fact, one of our partners, one of our affiliates of Blazing Trails is NASA, and they have 2 programs at NASA that we work with on a regular basis. One of those programs is Rockets to Race Cars. Let me tell you about that. In fact, I'll grab one of these brochures to show you. This is literally one of our jet dragsters, and Rockets to Race Cars talks about technology transfers that have come out of the space program and transferred into high-performance vehicles that all of us use every single day. Remember, a high-performance vehicle isn't just about being quick and fast. It's about endurance. It's about fuel efficiency. It's about economy. All the vehicles that we work with so hard nowadays are high-performance vehicles, more than we ever have seen before. Now, another one of those programs that we work with at NASA is NASA HUNCH. NASA HUNCH is a project that actually uses real high schools throughout the United States. HUNCH stands for High School Students United with NASA to Create Hardware. What does that even mean? NASA works with thousands of students, hundreds of high schools across America, and they actually build products that will make their way, if they pass quality standards, into space. NASA HUNCH literally has lockers on the International Space Station that are flying right now as we're talking on the International Space Station that were built by high school students. I'm getting so excited talking about this. Industrial sewing. Sewing is so important. Sewing in parachutes, sewing in spacesuits. All the sewing for the fabrics and stuff that happens inside that space station. Very, very special. In fact, we'll tell you just a little bit more about that. I just mentioned spacesuits. Let's kind of blend those two together between NASA HUNCH and rockets to race cars. Right behind me, I have a couple suits here. Now, well, there's a fire suit that was actually worn by Elaine in her very first jet car called the Mystifier. That fire suit is very different than this space suit that an astronaut wore, and similar in a number of ways as well. One of the ways that those suits are both similar is one of the materials that they use. That material is called Nomex. Nomex is a material that's a fire retardant material. It's a very common material nowadays that's used in a number of different applications that have to do with concerns about fire and keeping a person safe all the time. Well, let's bring it out. A couple other spots here. There's so many cool things. In fact, I should tell you that you yourself can do a personal tour at Larsen Motorsports by signing up and taking a tour and seeing all these live artifacts from the space program that NASA has on loan with us with Blazing Trails. Now, check this out. Right behind me are a bunch of seats. Now, check out this seat. That seat is actually one of the crew seats out of the Space Shuttle Endeavour. How cool is that? It is very different, though, than the other two seats beside us. The seat right here is to your right is what we call a raw pour. When we make seats for race cars, those seats are made with a pan, we call it on the outside of the seat, and then we take our driver. We look at things like size and shape of the driver, sometimes even gender, and we look at all of those things to do with the driver. We suspend that driver in midair using blocks of foam exactly where we want that driver to be in their full protective equipment, those Nomex fire suits, for example, their gloves, their helmets, all the fire retardant equipment, all the safety equipment. We suspend them, and then we pour this foam around the driver. That foam is energy absorbing foam that is there in the event of a crash. Now, that foam is, check it out, pretty rigid. It is not comfort foam like you would find on our couch or a pillow or something like that. It's a very specially made foam that's energy absorbing to protect that driver in the event of a crash. Now, this is, remember, what I called a raw pour. That raw pour had foam coming out all around the driver's helmet and all kinds of places as it expanded and as it cured. So what we would do then after we do that raw pour is we would take an electric knife, kind of like you use to carve your turkey at Thanksgiving. We take that electric knife and cut parts of the seats away. We carefully shape and profile that seat exactly where we want it to be to give all the driver all that room, all the comfort that they need driving the race car and still perfectly protect them. Once we get that seat where we want it to be, we cover it with a special material called Carbonex. This Carbonex is actually made out of carbon. You could literally take a blowtorch to this material and put it on the material. It looks like it's on fire. As soon as you pull it away, boom, self-extinguishes. All kinds of technology that's come out of the space program and is transferred into the world of high-performance vehicles. Check out behind me, here's something pretty cool. These tires are actually real tires. This is a tire that is a NASCAR tire that is used on a super speedway for NASCAR. It is the exact same part number that we use on the jet dragsters. The tire technology is remarkably similar from race car tires to a space shuttle tire. Yeah, you heard it right. This is an actual space shuttle tire. It's a main tire from the space shuttle that flew, and it was on the space shuttle Columbia. We talk about that tire technology, the similarities, the differences, and how that technology has transferred from the space program into the rest of the world of high-performance vehicles. We're going to make our way really quickly on around the corner here, and as we come to the area over here, we're talking about the business side of motorsports. The motorsports industry, it is a multi-billion-dollar industry. And with the motorsports industry, communications and marketing, the business side plays a massive part in the world of motorsports. And that's why here at Larsen Motorsports, we even include students that are from the College of Business at Florida Tech. Lots of things that that can happen here. There's a stage, there's a sound system wired in. We can do lots of presentations. Our partners, affiliates, and sponsors, they can leverage this space. It's all about supporting those people that support us right here at Larsen Motorsports and Blazing Trails. As we continue on this way, we're talking about some of those people that support us. Great companies like Northrop Grumman right here on Florida's Space Coast. Companies like Collins Aerospace. I'm going to talk a little bit more about them in just a minute. And we're coming up now on the U.S. Chemicals and Plastics Composites lab. But before we talk about that, let's touch one more time on the business side of motorsports. And I want to tell you, have you ever been to a butcher shop? Have you ever seen one of those pictures of a cow? And then you see a little arrow that comes up and it talks about what cut of beef this is. Maybe it's the tenderloins. Maybe this is where we get hamburger from. You like T-bone steaks, ribeye steaks? That cow shows you in that butcher shop where all those products come from. Well, check it out. I guess this is our car cow, I would say it. That's kind of weird, isn't it? But this poster talks about a bunch of different areas in the motorsports industry, and in particular, what we do here at Larsen Motorsports to include all of those other disciplines from the university and integrate those in a full business unit that operates a professional racing organization with multiple race teams. What are those degree programs? Well, just a few of them are engineering. We use people from with math degrees, aeronautical science, business degrees. All of those disciplines at Florida Tech, I bet you'd be hard-pressed to find one that doesn't fit perfectly right here at the Larsen Motorsports Blazing Trail shop. Coming on back, we're going to talk just a minute. We're not even going to go in this lab because I'm already hearing comments from a bunch of you that are saying you want to learn more about composites. Let's talk about that in another subsequent Blazing Trails virtual tour, but I'm going to tell you right here in the composites lab from U.S. Chemicals and Plastics that's supported by Sherwin Williams. A lot of stuff happens in here regarding aerodynamics. Now, aerodynamics, pretty unique area of motorsports. We build things in here out of materials like carbon fiber, things like fiberglass. Carbon fiber, great material, very lightweight, structurally very, very strong. Difficult to repair when we're out on the road. Remember, we are a mobile business unit. We're a mobile live entertainment business unit. That's what racing really is. And so sometimes we don't build parts out of carbon fiber. Some of those parts are built out of fiberglass. Fiberglass, super easy to repair on the road. If we have a problem, I'll give you a personal example. I was personally pushing one of our jet dragsters at Atlanta Dragway in Commerce, Georgia during their annual Night of Fire, and what did I do? I bumped the dumb thing into a fence post. I broke the fiberglass nose of the car. Not to worry though, because it was made of fiberglass. We simply went down to the local auto parts repair facility, picked up some U.S. Chemicals and Plastics fiberglass repair kit, got back to the track, and we had that race car ready to race. We didn't miss one round of competition. We had it ready to race in only about an hour and 30 minutes. What else can we use? Now, that was a fairly small piece that we built. That was actually the nose of one of our jet dragsters. We build small aerodynamic ducts. We build the seat pans that we talked about on those seats that we just came back from. And then we have big stuff here. Funny car molds. Well, what is a funny car to begin with? In the early days of drag racing, some of the competitors wanted to assemble cars that were lighter, more aerodynamic. And one of the ways to do that was to build parts out of fiberglass or composites. They actually built fiberglass doors, the front end, the hood, the deck, the tail, and the deck lid, maybe even the bumpers of the cars out of fiberglass to start lightening up the metal materials that the cars were made of. When they did that, somebody said, well, geez, let's just take this and let's bond the doors to the body. Let's bond the front end to the body. Permanently mold the hood and the trunk into the body. And at that point, they ended up with a one-piece composite shell for that car. Well, some of those composite shells, racers, as innovative as they are, they started modifying little tricks here and there to make it more aerodynamic, make it push its way through the air a little bit slipperier. And somebody said, well, geez, that's a pretty funny looking car over there. That funny looking car got to be known as a funny car. The name stuck, and in professional drag racing today, we have a number of different categories, including jet cars that have funny car, one-piece composite bodies on them. So here at Larsen Motorsports, I told you earlier, what do we build? We build jet funny cars. We also build jet dragsters. Now, aerodynamics, let's talk about those, because the outside of these molds looks like there's a bunch of stuff hanging off from them, and we're really lucky. We got these molds. These are 3 very, very popular molds to make jet funny cars out of. We actually got these molds from Harry Glass, one of our great affiliates and partners, just a little ways north of us in Jacksonville, Florida. Harry West at Harry Glass built a number of different very, very popular funny cars. Harry West was a genius with aerodynamics. So let's look up underneath the body here, and I'll show you that the part that counts on the mold is up inside. Now you can see it's very smooth up inside here. This is exactly where you would lay up all that fiberglass or carbon fiber, whichever material you chose to use. And you can see there's a seam right down the center. Once the fiberglass or carbon fiber cures, you simply unbolt the halves and blow the thing apart with compressed air, blow the body out. There's a body that'll come out of there. In fact, you're going to see one here in just a minute as we continue our way down the tour. Now, we talked about aerodynamics for a second, and you can see these cars become really slippery as they can push their way aerodynamically efficient through the air. A lot of people ask me all the time, it seems like I have people asking me, do we use wind tunnels at Larsen Motorsports in order to aerodynamically test the cars? And the answer is no. In fact, we almost never use wind tunnels, and the reason for that is because the aerodynamics of the car completely change once you start the engine. These engines that we're going to see over here, those engines use the velocity at the engine inlet, this enormous 16-inch hole. As air is continuously going down that inlet, the air is moving about 250 miles an hour as it enters that engine inlet. The air coming off the back of the engine, out the exhaust, is moving nearly 1,800 miles an hour. It is really moving. So what is the process we use to aerodynamically test the cars? We use a software program given to us by Siemens Software, Siemens Corporation, called CFD. What does CFD stand for? Computational Fluid Dynamics. And you're going to be amazed at all the data that we can receive from that computational fluid dynamics program. In fact, the aerodynamics themselves are worthy of a separate Blazing Trails virtual tour. And the people that love slippery stuff that you want to modify it as much as you can to push it through the air, there's where you're going to have a lot of fun, is on that Blazing Trails CFD, Computational Fluid Dynamics virtual tour. Aerodynamics, really important for a bunch of reasons: to make the race car push its way through the air faster, but also for aerodynamic downforce. People always ask me, what does it take to keep one of these cars on the ground? It's an airplane engine, fair enough. It wants to fly, doesn't it? So aerodynamics become extremely important. Here's some of those components that we use to keep the car on the ground. Things like that front wing that's up by the nose. Aerodynamic ducts, those NACA ducts. The engine inlet itself, very important to have the airflow. You know it's going 250 miles an hour. It's grabbing air from everywhere around that car to feed that engine. One of the ways that we keep the car on the ground, here it is right here. We actually tip the front of the engine 1 degree down so that the engine is actually tipping the race car, driving the race car into the track under power. It helps create a huge degree of stability out of that 1 degree down angle. You can see that the engine that's in this car, it came right out of one of these. This is a Northrop T-38 Talon. Lots of aerodynamics there in that supersonic fighter trainer. Moving on forward. Coming this way. Wow, look at all these engines. I love this spot. There's really two different types of engines that we use in jet racing. All of these engines, almost all the way down, these are engines made by General Electric. They would be exactly what was used in that T-38 fighter trainer that we just talked about. All of these engines are ready to go in a race car, and anything certainly with cardboard has already had the core of the engine overhauled by students right here at Larsen Motorsports. We have aerospace engineering students, we have mechanical engineering students that work on those engines, lots of different degree programs that apply right here at Larsen Motorsports. Mechanical engineering, let's go right in here and show you a piece of equipment that Collins Aerospace donated to our program. An amazing piece of equipment. It is a 3-axis CNC mill. What does CNC stand for? A CNC mill basically is an automatic device. We program the mill. I'll open it up here. Oh, in fact, they have an engine mount sitting right inside right now. I'm going to grab an engine mount over here as well. We can literally take a piece of aluminum, any type of material, maybe it's carbon fiber, maybe it is whatever that material might be, and we can put the block of material in the mill here and push a program. In fact, well, check it out. There's the control head. Yeah, it's all Siemens stuff as well. And so we take this Siemens program and we use CNC equipment, computer numeric control. CNC stands for computer numeric control, and it will automatically, with the computer program, make this engine mount. Some of the programs that we use, certainly not limited to these, but Siemens gives us some really great stuff. NX and Solid Edge, those are the two primary programs that we use to do all the CNC machine work right here on the CNC mill. Oh, thank you. I got a water. That was nice. All right. Perfect. Well, we're working our way on back to the ends. Oh, you guys are already shooting us a bunch of questions about engines. All right, we see that. Well, let's talk about jet engines. Now, I will tell you that the jet engines, this is an area that is going to have plenty of room for an entire virtual tour of its own. And that's coming up really soon. Remember that there's two primary engines that we use here at Larsen Motorsports. Those two engines are the General Electric J85, which I have right here, and the Pratt & Whitney J60, like the yellow engine right behind us. So those are the two engines that we use. What is a power plant? Sometimes we refer to these engines as a power plant. A power plant is an engine and all of its related parts that supply the power of a self-propelled object, that's our jet dragster with that driver in it, such as a rocket, jet dragster, or any other vehicle. That's what a power plant is. Let's talk about the engine that you're seeing right here beside us. In fact, check it out. This is a cutaway, what we call a cutaway engine, and the General Electric J85 that's in the Florida Tech jet dragster, the U.S. Chemicals and Plastics jet dragster, all these cars that we have around here, except one funny car that has a Pratt & Whitney J60 in it. This is identical to those engines. It's just cut away so that you can look inside. But I have something that will help us out a little bit here as well. Let's talk about the engine, and we're going to limit our conversation today to the three primary sections that every single jet engine ever made has. At least these primary sections, sometimes more depending on the type of jet engine that it is. But every jet engine has an engine intake, that's right here, and a compressor section. The compressor section on this J85, just like right here, has a bunch of blades that are inside the compressor. Those blades are connected on a common shaft that goes all the way back to the turbine wheels in the back. We'll make our way back there in just a second. As we get through the compressor section has these blades. You can see they're really big blades in the front. They work their way down to smaller blades, and if you actually were able to measure the angle of those blades, you'd see that the angle gets steeper as the air works its way back in the compressor section. We're going to compress the atmospheric air pressure of around 15 psi, right around 14.7 psi is the standard atmospheric pressure. That changes, of course, with weather conditions. We're going to compress that air through this big open hole that never closes. It never closes in a jet engine to about 70 psi in a General Electric J85. At the point that it's super, super high pressure, the air is already moving close to 1,000 miles an hour as it enters the main frame of the engine here, where all of these fuel nozzles, those silver fuel nozzles and that silver fuel manifold, introduced fuel to the engine right here in the combustion section. The second main section of one of our engines is the combustion section of the engine. At this point, we introduce fuel. Now, the ignition in the jet engine, once the fuel is lit, the ignition can be turned off. How do you shut off a jet engine? Take away the fuel. We're going to talk a little bit more about that in one of those subsequent tours. Super, super high pressure, a massive thermal expansion of that energy happens right here in the combustion section, and the air comes back in the combustion section to the turbine section. The turbine section, or these turbine wheels right here, are there for one purpose. That is to extract energy from that high pressure gas path, we'll call it. As the air comes back through the turbine wheels, they extract energy to help draw the air through and to drive all of those other mechanical components in the engine. Very, very powerful air. As we leave the engine, the air is actually moving around 1,800 miles an hour at the back of the exhaust duct here. Where does all that pressure, where does all that push come from? If the engine is mounted in an airplane, the push is the exact same spot as if it's mounted in our jet dragster. As the engine pushes its way down the track, the push of the engine is not out in front of the engine. It's not even right here where the engine mounts are. All of that center of pressure is on the face of the rear turbine wheel. The turbine wheel that is the furthest aft turbine wheel, all that pressure is pushing against the face of that turbine wheel. Let me tell you one more amazing fact about these engines before we move on. Lots of energy. How fast is this engine turning? This engine is going to be turning at full throttle at a staggering 17,000 RPM, 17,000 revolutions per minute. How many revolutions is that per second? Quick math. It's over 280 revolutions per second that this engine is turning. Those blades, every second, 1001, 1002, are turning 280 times every second. Woo, that's going to make my old pump almost stop, you guys. This thing is really moving. There's a lot of energy there. You need the best technicians and the best engineers in the world to make sure, from a safety factor, that those engines are doing their job. All right, coming on back here now. Remember when I told you about the business side of motorsports? Well, Larsen Motorsports and Blazing Trails, it's almost like actually, Larsen Motorsports and Blazing Trails are two separate organizations, but within the walls here at Larsen Motorsports, it's almost like we have two separate Larsen Motorsports companies as well. We have what happens back here at Larsen Motorsports all around the shop that you're taking a tour in, and then we have that road component, the racing component. We travel to races all the time. Now, let me tell you about the group. There's so many people that are so important to that, but a lot of times the people that get forgotten are the communications and marketing and business people and business students that are involved in racing. Just the graphics alone. Think about the graphics on all of these shirts and all the items that we have here. Check that out. There's some of the Blazing Trails and Adventures of Blaze comic books. All of those comic books, all this stuff is developed and designed by Elaine and her team here at Larsen Motorsports that is comprised of business, communications, and marketing people, and all the students are right here from Florida Tech. That being said, I want to remember to be sure to ask you to like, share, and subscribe to LMS Jets. Like, share, and subscribe at lmsjets.com. Follow us on our social media. It is so important. In fact, our team even posts every Thursday at 4 o'clock. A new video drops on YouTube and Facebook, and you get to see the real deal. It's what we do every single day right here at Larsen Motorsports, involving all of those students, all of our business partners, our affiliates, all of those people that work with us right here at Larsen Motorsports. This trailer that you just saw was is actually used at a lot of the races. It transports the mobile communications business and marketing components of our company right there to the racetrack. Now, check it out. We're not going to make we're not going to make a real stop here, but yeah, there's those jet funny cars. That's what they look like when they're done. In fact, the one on the right-hand side, that's that lone car that's owned by our highest time crew chief, Mike Mathis. He loves those Pratt & Whitney J60s, and that's the only Pratt & Whitney J60 powered car right here in our shop right now. Look at all the graphics. Look at the graphics on the trailers that transport the race teams to the racetrack. There's your U.S. Marine, Dwayne Hill, drives that Dominator jet dragster, sponsored and presented by U.S. Chemicals and Plastics, a Sherwin Williams company. There's Elaine, there she is. She's in that Florida Tech fire suit, isn't she? Simpson Racing Products has done an amazing job to keep all of our drivers safe. And they work so hard all the time with safety equipment, fire protective equipment, even the harness system, this restraint system in our race cars is supplied to us by Simpson Racing Products. Well, we are going to make our way back over here to a couple of our jet dragsters. These are the jet dragsters that you've seen out at the racetracks for the last couple of years. The Florida Tech jet dragster that Elaine drives has been an amazing car. I'm going to show you that it's on its way out, because she's going to have a brand new hot rod that you're going to see in just a minute yourself. And then, of course, we have the U.S. Chemicals and Plastics Dominator jet dragster, driven by your American Marine, Dwayne Hill. Now, we've taken the body off the jet dragster here so that you can see a bunch of the components inside. We're going to talk a little bit more about the chassis here over in our final assembly area and some of the chassis assembly. There's going to be a major virtual tour about chassis construction and the assembly, the basic frame assembly of these jet dragsters. But look here at the dash of the jet car. Now, our jet cars are built almost identical from one to the other, and we work really hard to make the job of the driver as simple as we can. Believe me, I've seen videos with live cameras in the cockpits here, and you will too if you follow us on that YouTube and Facebook channel. You're going to see how busy these drivers get sometimes when things start going not their way. The driver's compartments are fairly simple at first glance. There is not a speedometer in one of these cars. A lot of people ask us if there's a speedometer in a jet dragster, and there's not. The instrumentation is very important. We only put the instrumentation that is critical to the operation of the car. So you can see here, we have a tachometer that reads in percent of RPM. We're going to talk about what that even means. What does a percent of RPM mean during that virtual engine tour that we do in a subsequent video? There's a low oil pressure light. When that light turns on, now there's no oil pressure. I just turned on the master switch, and how come there's no oil pressure? Well, the engine's not running, is it? So there's a low oil pressure light, and then a very critical instrument to a jet dragster or any type of jet engine powered vehicle. One of the most important times in the life of that engine is, in fact, when you start the engine and the driver's looking at that exhaust gas temperature gauge like a hawk, looking really close at that exhaust gas temperature gauge every single time they start the car, and honestly throughout the operation of the car as well. Now there's some other pieces in here. There's a throttle. The car has a hand throttle. There's an afterburner fuel switch on the top of that throttle, and then we have a couple levers here. The first lever right here is the primary parachute. We're going to talk about that in just a second, and then if the primary parachute has a problem, at any time that driver can put out the emergency parachute or the reserve parachute. There's also provisions built into the car, safety systems installed in the car to help the driver if the driver for some reason gets into a situation where they are not able to deploy these levers. The car will automatically shut the engine off and automatically deploy the parachutes. As we go through the jet dragster, if you were able to look up inside the floor of the jet dragster, you would see 4 pedals up underneath there. What are those 4 pedals? Well, I just told you it has a hand throttle, so what can all 4 of those pedals be? Well, there's actually 2 pedals that are stationary pedals. Some people call those pedals, they're basically footrests, but those 2 pedals, those 2 footrests are there for the driver to brace themselves during the deployment of those parachutes that we just talked about. And then there's 2 brake pedals. The car has differential braking. Our jet dragsters and jet funny cars use 2 brake pedals that have to be perfectly manipulated. Jet car drivers have an incredibly unique skill set. They actually have to pull the car up to the starting line at the racetrack and stage the car. When you bring the car up to the starting line, the actual starting line has infrared beams that cross the racetrack. When they stage that car, they're going to stage the car at full throttle, at wide open throttle. The engine alone, before the afterburners even lit, is going to be making nearly 2-to-1 power to weight ratio, and the driver has to perfectly manipulate those brakes. Now, it has brakes. It does have 4-wheel disc brakes. If you look over there on the back of the Florida Tech Jet Dragster, you'll see disc brakes on the back of that car, on that rear wheel hub with the tires removed. But what do we stop the car with? The primary method of deceleration on a jet-powered race vehicle is a parachute. Now, I'm going to get this board here to show you what that parachute looks like, and it is fairly different. In fact, check it out. Remember the space program we talked about? There's a capsule from a spacecraft coming back to Earth. It's parachuting back to Earth. Now, those parachutes are what we would call a ring slot parachute. They're round. They're made to very stably, in a vertical way, bring that space capsule back to Earth. That's super different than a race car parachute. The race car parachute is what we call a cross-form parachute. That's what we use here at Larsen Motorsports, is a cross-form parachute, and that parachute is actually going to be attached to the back of the jet car right here with a big long lanyard. Now, the parachutes are stored in these cans on either side. I'll check it out. We have 2 levers up in the front. The lever on the left is the lever for the parachute can on the left. The lever on the right, that's that emergency or backup parachute, is right here for the can. The parachutes are actually stored up inside the cans here. And then when the parachute is deployed, there's a spring-loaded pilot chute that comes out. And that spring-loaded pilot chute looks just like this. Inside that can is the spring-loaded pilot chute. When the driver deploys that parachute, this comes out, gets into that very fast-moving airflow, comes out, and it pulls out the main canopy of the parachute. The main canopy of the parachute is made of a special material called ripstop nylon. Very special sewing. It's some of that industrial sewing that we talked about back with the NASA HUNCH program. In that program, you would learn how to make and use industrial sewing applications like parachutes. And then when that parachute comes out, it pulls out the tow line of the parachute here that's anchored right down the center line of the car, pulls really hard on that car. Sometimes up to 5 Gs of deceleration when the parachute is very aggressive. We want to make sure that the parachutes are perfectly installed and perfectly packed every single time. Well, let's talk about the final assembly area, the area that we're going to put these cars together. Here at Larsen Motorsports, we have a couple different areas, and the final assembly area of Larsen Motorsports usually has at least 2 cars in it. Now, here's a car that is the last of our 5th generation cars. We had the help of a company on the west coast of Florida, Worthy Motorsports, that in our transition here to the new Larsen Motorsports location, Worthy Motorsports did a great job and built us a bunch of cars. This is the last of those cars that they built. Our brand new 6th generation car. Remember I told you that our brand new 6th generation car was going to replace that Florida Tech Jet Dragster that we just saw over in its racing operations area. The Florida Tech Jet Dragster it's going to get retired. It's been a good one though for sure, and it's going to get replaced with a 6th generation car. The 6th generation cars were developed for one reason and one reason, truthfully, one reason only. And that was for research and testing of products. A lot of those products are going to have to do with human-centered design, human-centered research, and the 6th generation jet dragster that's behind me, this is serial number 1. This is going to be a Florida Tech jet car yet this year. And yeah, Elaine's gonna get her new hot rod after about 5 years of running those those really, really great 5th generation cars. Let me tell you about the chassis of these cars. Now, the chassis itself is going to be another area that we want to take a full section of a virtual tour to show you about the chassis. But in short, the chassis are made of normalized 4130 chromoly steel. What does that even mean? Normalized 4130 chromoly steel is what the chassis or the skeleton of the car is made of. Now, in racing, of course, we want very lightweight components, as light as possible. If I look at this chassis, it seems like some of the tubes are just huge. That's got to be super heavy, right? Until you think about the skeleton. How about the skeleton of something else that has to be light? How about the skeleton of a bird? Well, what do we all know about the skeletons of a bird? Yes, they're hollow. And that is exactly the same as the hollow tubing that is used to build our chassis. Now, that piece of steel tubing, that piece of 4130 chromoly steel looks pretty darn big until you look how thin the sides of the tubing are. In fact, we use tubing here that is designed so that it has a perfect fit, so that the next smaller size is designed to telescope inside the next size bigger. And then once we build the cars, we will weld this. Now, as we weld the chassis, I'll give you a little bit of stuff here about that chassis virtual tour. But as we weld the cars together, there's a lot of very special angles that we use as we put this thing together to increase the surface area of that weld, and also to put little holes in here the design and everything comes straight out of the aerospace industry that's used all over Florida's Space Coast here. We have these holes called rosette welds. We're going to tell you a little bit more about those rosette or plug welds in that future video. The chassis, though, are designed to sustain the G load, if you will, all those forces created from accelerating down the racetrack and also from deploying the parachute. When we design the cars, you have to remember that we have to look at the full range, even the transportation of the car when it rides in its trailer as it goes around across the highways here in North America to and from all the shows, the events, and the races that it goes to. So now we are here at the final assembly area, and that is the final location of our virtual tour. We have a nice amount of time that we've designed in the tour to help answer some of your questions. And so we're going to do a quick question and answer session here. I've got some of my helpers here that are going to actually tell me about some of the questions that you have. And I know this has been a really quick virtual tour of Larsen Motorsports. We did that by design because we know that, hey, we're in a very unique situation right now. The circumstances that we're in worldwide, our normal schedules have been interrupted. And so with the opportunity that we have here, we are going to have a number of these Blazing Trails virtual tours at a number of locations, but we're going to talk a lot about what happens here with the students from Florida Tech and all of our affiliates, all of our other partners that support what we do every single day and support these students all the time. Any questions that you have for me?
So, for one question, I know a lot of these questions have been answered already by Brian Tachi, our Director of Operations, but one of them was, what is the difference of the suits with the race suit and the space suit?
Oh, that's a really good question. Now, I will tell you that obviously we get a ton of space questions, partially because we live right here on Florida's Space Coast, right beside Kennedy Space Center, and of course all of those great parts that have been loaned to us by NASA to support the HUNCH program and to support rockets to race cars. But what are some of the differences between the space suit and the race suit? Well, I already told you, and I think it might have even been one of the test questions about what are the materials made of, and that material is Nomex. If you looked at that spacesuit, if you rewind this video later and you look at that spacesuit, you'll see tubes that go into the driver's, to the area of the astronaut's hands. There's a bunch of things. And so a lot of those tubes have to do with pressurizing that suit. Now that particular suit is a re-entry suit. A lot of times with the G-forces that an astronaut sees, and you know, some of those G-forces, even though they may not seem as high as some of us, you know, we may see some similar G-forces even in these race cars, but let me tell you, those astronauts go through an amazing transition as they launch into space, and those are really heavily sustained forces of gravity. And so a lot of times that G-suit, they have to inflate certain parts so the so the astronaut's blood stays where it belongs in order to keep the astronaut from blacking out. Even the colors of those suits are going to be described in one of those future videos that happens with our own aerospace engineering student, Lauren Ann Graham. She's going to hook you up with a bunch of those answers, so keep following us on those subsequent videos. Logan, what do you got?
So our next question is, how does tire pressure affect a jet car's performance?
Ooh, how does tire pressure affect a jet car's performance? That is a really, really good question. Now, with our jet cars, a lot of times the tire pressure is set based on atmospheric conditions. It's also set based on track conditions. Ultimately, a jet car blows itself down the racetrack. There's no transmission, there's no differential. If you're a drag racer, some of you have seen those wrinkle wall slicks that are so important to getting traction on the starting line and on down the track. Tons of engineering in tires, massive amounts of engineering in tires. To a jet car, very interesting. We want as much contact patch on that racing slick as we can on the track, on the starting line. If you think about a jet car, that very unique skill set that jet car drivers have, they have to hold that car back on the starting line with that engine at full power as they stage the car. When they leave the starting line, they release the brakes, accelerate on down the racetrack, and then those tires have to be perfectly engineered and perfectly set to the right pressures for stability of the car as it goes down the racetrack. Logan, what do you got?
So does the parachute slow the jet down?
Does the parachute slow the jet down? Now, the parachute slows the jet car down, but the jet engine itself is still spinning. When the driver gets to the end of the racetrack, the driver will shut off the engine by taking the throttle and putting it in its cutoff position. That cutoff position actually shuts off the engine completely. At the same time, there's a little tab on that lever that at the same time it deploys the primary parachute. All of a sudden that parachute comes out. The parachute itself controls the deceleration of the car. The engine itself, though, is still what we call windmilling down. The engine is still churning, and in a way, I guess it's still making thrust. Even though it's shut off, the engine itself doesn't lock up and come to an abrupt stop. It is still spinning and windmilling down. At the end of the track, as the driver turns off the racetrack, the crew, the support crew that's down there to tow the driver back to their pit stall, actually sees and hears that engine windmilling down. And if you follow us on our social media videos on YouTube and Facebook, you will actually see that because we have cameras all over the car and at all different places on the racetrack. You're going to see that yourself. You'll hear that engine windmilling down. Logan, what do you got?
Someone said, I thought you guys ran NASCAR tires. Love what you guys do for the kids in school.
Thank you. We do run NASCAR tires, and they are the only approved tires that Goodyear approves for the sanctioning bodies that mandate the part numbers and models of tires that we have to run. And we do love working with these students. At this point, I will tell you that Larsen Motorsports, our primary goal with our company is to use programs like Blazing Trails to reach out to students and help develop the next generation of motorsports professionals, whatever you might want to be. And actually, it's not just motorsports, it's all high performance vehicles. If you want to work on spacecraft, if you want to work right here in town for Northrop Grumman or any of the other great companies, United Technologies with Collins Aerospace, Pratt & Whitney, engine manufacturers, all that stuff is based right here in Florida and across America. This is the place to go, and we love working with those students that turn into future employees of our partners.
What does the fin on the front of the jet car do?
What do the fins on the front of the jet car do? Those are these wings. Now, this one is here. It actually has these little dots on this side and has some powder left over from some aerodynamic modeling that we do. Remember that CFD modeling? Well, we actually have a scanner that can scan the entire car. And with some of the areas that are kind of shiny, we have to put this special powder on here. We put all these dots, and we actually use a 3D scanner to digitally model the car. At that point, we can check the aerodynamic analysis of the car. What does the wing do? What does the fin or wings do right here? The primary reason for those to be here is for stability when the parachutes are deployed. If you think about the parachutes that are mounted up above the afterburner, as the car goes down the track with that 1 degree of down engine angle in the car, fairly stable as it goes down the track. Get to the finish line, pull that throttle and pull that throttle, put the engine in cutoff, turn the engine off, put that main parachute out. That parachute is going to pull above that afterburner. It has a tendency to rotate the car like an airplane taking off, and it'll pull the front end of the car off the ground. Doesn't bother the drivers too much. In fact, if you ask a couple of the jet car drivers that are some of my mentors, Bob Motes that drives that big King of Quake jet semi truck, I asked him one time, I said, Bob, the front end of the truck comes off the ground when you pull the parachute. He says, that's okay with me. He says, that just tells me I got a good parachute behind me. And then as the car decelerates, yeah, that front end just comes right back down. What are those wings there for? The canard wings are to help assist keeping the front end on the ground when the parachutes are deployed. What do you got, Logan?
How long does it take to make the jet dragster?
How long does it take to make the jet dragster? That's a tough question. Here at Larsen Motorsports, there's very little that we do without having students involved. The internships here, for the students that are here, are not pushing a broom and hoping through osmosis that they learn something as they walk by people that are actually doing the work. The students are the stars, the students do the job. And so we have these Florida Tech students that are involved in every single aspect of the build of these cars. And you learned, even College of Business, communications and marketing students. This is a fully functional, professional racing organization with multiple race teams, and we use all of these students in a number of different capacities. Now, what if I'm not a college student? Well, if you're lucky enough to live here on Florida's Space Coast, we even have job shadowing programs for students from some of the local high schools. But remember, you yourself can stop here. You can schedule a visit at Larsen Motorsports anytime that you want. Schedule a tour, and we will give you a personal tour of the entire facility. If you're in Florida on vacation, come and see us. Make this one of your stops. What else do you have, Logan?
How much fuel does the car use?
Ooh, that's a big one. Well, you saw those big old fuel tanks mounted on the either side of the back of the car in front of the rear tires. The car actually holds about 23 to 24 gallons of fuel. Now, we have to refuel it every time it goes down the racetrack, and the fuel consumption is very high as it goes down the racetrack. In fact, with the afterburner lit and the engine at full power as we're going down the racetrack, the fuel consumption is somewhere, can reach potentially be around 1 gallon per second. Now, that doesn't make any sense, does it? Because we have a whole lot more fuel than we need for that 5-second run down the racetrack. Where does the other fuel go? It goes in a really cool smoke and fire show that we do before we run down the track. The drivers, we know that all those fans in the stands love to see smoke and they love to see fire. And so the drivers know how to give them a great show, and a lot of the fuel is used during that smoke and fire show. Now, our drivers are very professionally trained. When they get that fuel leveled right down to where they have just enough fuel to make it the rest of the way down the track, yeah, they're going to get serious. They're going to say it's time to rock and roll. They put that, they get out of show mode and get into the gloves off, fists up, ready to fight each other all the way down the racetrack, and they're ready to rock and roll going down the racetrack. What do you have, Logan?
So someone actually asked us if we're going to be doing Cleetus and cars this year. He said, sorry about asking about another race team, but that's where he learned about you, Jen.
That's cool. I love Cleetus and cars, and yes, we are. We're going to be doing Cleetus and cars this year. In fact, that was our very next race that we are going to on April 4th. Now, Cleetus and cars in Bradenton, Florida has been moved back to May 30th because of this virus situation that all of us are in. Those are awesome shows, and we're going to be at the Cleetus and Cars shows We will be at Cleetus and Cars in Bradenton, Florida twice this year. We've already been in February to Houston, Texas for the first Cleetus and Cars, and we're going back to Houston, Texas for the next Cleetus and Cars. I think it's in September. And so, yeah, we're going to be at 3 more Cleetus and Cars events this year. You're going to see our jet dragster. Maybe you'll even see this brand new Gen 6 jet dragster. That'd be cool, wouldn't it?
How much horsepower does a jet car have?
How much horsepower does a jet car have? That's a tough question. The truth is there's no real direct correlation between the thrust of a jet engine and the horsepower of another type of internal combustion engine. Now, keep in mind that a jet engine is actually an internal combustion engine. It wouldn't stay lit if we left the atmosphere like a rocket does, and these are not rocket cars. But how much thrust or how much horsepower does a jet dragster have? Well, if you do the math, if you take a standard formula for horsepower and you figure out what the mass is of the car and how much energy it takes to move this certain level of mass over a certain distance, over a certain distance over a certain period of time, you're going to find out that our cars have roughly 4,000 horsepower, even though there really is no direct correlation to thrust and horsepower. That was a really good question. You could have a lot of fun with the math involved with that.
What is your most enjoyable moment of a race?
What is my most enjoyable moment of a race? When those cars stop and everything, believe me, you watch our videos, this old man becomes a nervous Nelly when it comes time to get up there and race, and that's because it is so serious. What's the most enjoyable moment that I have? I'm telling you, the most enjoyable part that I have of a race is seeing our teams go down that track and the amazing chemistry that our teams have, whether it's a student, whether it's an employee, whether it's the driver, the crew chief. All of that chemistry comes together. A lot of people have asked me, what does it take to make a great race team? Well, you can have a great car, you can have a great chassis, great wheels and tires and brakes, you can have a great engine, you can even have a great driver. What does it take to make a championship level race team a great race team? And I tell everybody the exact same thing every single time. It's the chemistry of the team. It's the ability for all of those people to work together in unison, to work together towards one common goal. And that is exactly the answer that I would have every single time. The most important part of our teams and the most gratifying thing for me is seeing the chemistry of our teams come together. And honestly, jet racing is an amazing category. It has some amazing participants, and we're just always so excited to get together with other racers and see what they're doing as well. What do you got, Logan?
So our last question.
How
much power does it take to start a jet car?
Ooh, how much power does it take to start a jet car? If you look in the back of the crew trucks, and you'll see those trucks if you follow us on social media on all the videos and so on, in the back of those crew trucks, there are battery packs. Now, we are very lucky that we have Brute Force Batteries as one of our sponsors. We get great products from Royal Battery Distributors that have a bunch of locations throughout Florida here, and they keep us with some extremely powerful Brute Force batteries. We use three medium-duty truck batteries. They're actually medium-duty semi-truck batteries that are wired in series to turn a very, very powerful electric motor that is mounted to the jet engine to start one of these engines. It takes a massive amount of power. In fact, the very heavy-duty cables that we connect to the cars with to start these engines, because the batteries are mounted in that crew truck. Those cables are about the diameter of my thumb. When the driver depresses that starter switch, I'm so excited about it, I can't even talk. When the driver depresses that start switch, there is so much electromotive force, that magnetic field that flows around anything that has energy, electrical energy energized through it. It is so powerful, it takes those two cables that are connected to that starter and actually separates them in a lot of cases. It takes a ton of energy. That starter will draw almost 600 amps. So it takes a lot of power, and we have to charge those very powerful batteries every single time we start the car. Guys, that wraps up our virtual tour that we have here today. Logan's going to come in one last time. I'm going to give you the mic here, Logan. Thank you, everybody, for following us on the Blazing Trails virtual tour. I hope that you have a good, safe time off from school, from work, whatever it is that you're doing. Logan, finish this up for us. Thank you, everybody, for following us on our tour. Here's Logan.
Hey, thanks guys. So we hope that you enjoyed all of that. One of the 2 files that you guys downloaded before this tour or were given from your teachers is a follow-up activity. That follow-up activity is really awesome because it gives you a chance to create your own race team. So make sure to look for that in the files that you've downloaded, and we really hope that you've enjoyed this day. We'll see you soon.